Okay, so um, I can share open up PowerPoint and then I show my screen. What am I sharing? I'm sharing the vector stuff. Okay, let me open up browser and let me open up slides. Alright. And then we're gonna focus on chapter 2 and 3. So for that, this is a quick review for chapter 2. And I'll have more people coming in. Welcome, welcome. Okay, so let's see. Okay, so a few concepts and then we do some exercises and you can ask questions throughout the review and I will post it online for you guys to be able to study. I will post the exam tomorrow and you return it on Sunday. Sorry, yes, on Sunday or Monday. Okay, so very quickly, the goal of this section is to understand that forces are expressed. Okay, so the concept is pretty simple or interesting, I would say. So you have a few ways to look at physics on a macro scale and in a micro scale. And micro. Macro scale is what we're learning right now, is the Newtonian view of classical dynamics, classical physics, where forces are could be a small soccer ball or could be a huge planet. And then their force is going to produce an acceleration. And if it's not moving, it's going to produce a weight. Well, actually, if it's not producing, it's going to produce a reaction on other stuff. The difference of moving versus not moving is that when it's not moving, the acceleration is zero, but it's based on the same equation, F equals ma. Okay, if you not in this class, and depending on what you study, you might not even go that deep. But if you look into a microscopic approach, that's where you use partial differential equations to see kinematics, and then you can have even more more comprehensive theories like quantum theories, where let's again, not part of this class. Oh my gosh, we're gonna get a huge group. That's good. So again, in this class, we're gonna learn about macro um, cosmos, right? Like how forces are represented for big bodies, for cars, for trains, for airplanes, for basketballs. And for those of you who are just joining, I was mentioning that in other fields of physics, you will understand more microscopic views, kind of like um, as I was saying, like how things move in a field, an electric field, fluid field. Those are with finite elements, with finding the fields in terms of partial differential equations, etc. And then you have way more advanced things like quantum physics. All this is just introduction, where you're using completely different equations, where you're dealing with imaginary numbers, where you're dealing with magnetic properties. So in a view, this is a very simple way of creating a system of forces. So you have to train your mind to see it as a simple system that is going to assume a lot of things. You're going to assume that the whole mass is the same, the whole density is the same, where in reality a bridge has bolts from titanium, beams from carbon steel, road from asphalt, cars on top that are aluminum and rubber and plastic. But in a system, the whole thing can be simplified into 2 or 3 different materials. Okay, so when you study forces in that type of view, a macroscopic view, statics, forces have only 2 qualities. They have a direction and then have magnitude. The direction is expressed typically in this class. We'll always use Cartesian coordinates. That means X, Y, and Z. Okay, X, Y, and Z. So you have angles with respect to X, angles with respect to Y, angles with respect to Z. If it's only 2D, then simple, you don't care about Z. In that case, I want you to go back to your trigonometry class. We don't have time to study that right now, but I would appreciate it if you have questions about that. Ask me, or like in a different setting, or go to your trigonometry class. But you only need to know a few things. You only need to know sine, cosine, and the sine rule, which is one of the videos. And so if you have a force, sorry, a system of coordinates, let's say this. Let's set up a system of coordinates. And this is X and this is Y. And then you have a force. Say that this point is an airplane, and then it's starting to lift. So you don't care. You don't care. The airplane itself is going to have different angles of attack, but you won't care about the whole mass. At this point, you can simplify it as a whole sphere for this class. For fluid dynamics and other stuff, you can't. And then the vector, actually, pilots use the term vector. The vector for that lift, say, is 30 degrees. So in our terminology is X and Y, and their terminology is horizon and lift. So if you want to know what is this vertical distance from the ground, you can use, this is what I'm saying, right? You can go to your trigonometry class, there's plenty of material that I already posted on module 1. So this distance, Y prime, is this distance, L, and then this is sine of 30, right? Sine of 30. Sine of 30. I don't have a pencil, so I apologize. And this one is this distance right here that is traveled horizontally is cosine of 30 times its hypotenuse. This is something that you already know from high school. Okay, so we need to move on. A force, remember, this is in meters or in kilometers, or in inches or whatever. This is distances. A force has components. Remember, a force has magnitude and direction. So the magnitude would be F, and the direction will be with respect to the coordinate system. Okay, so those components are in units of force. The distances are in units of distance. Okay, and they're correlated because when you have acceleration, then they will tell you how fast and where you're going. But if they're at 0, then you just need to know where they're applied. So if there's no acceleration, so remember, F force equals ma, where m is mass and a is acceleration. If there's no acceleration, force is 0, but force is 0 in the system of forces. So if you have a force here, then you have a force here, then for this to not move, to not have acceleration, means that the force that is applied here is the same that is applied here. That's why there's like a meme and a joke of somebody trying to open the door from this end and this one trying to open the door from this end, and the door doesn't open and they think it's locked. It's because both of them are applying force at the same point from different directions. If both forces were applied at different locations, then this thing will move kind of like an airplane. There some turbines are on the wing, some turbines are on the rudder, right? That's why it's important, the direction. All right, that's the concept. So that's module 2. We'll do examples at the end. Then module 3, if you have a system, I think somebody else is trying to get in. So far, any questions? Any concerns? All good so far? All right. Okay, so remember, this is going to be posted. There's a recording. So, all right, that's the concept of forces. Oh, another thing before I move on. So, a force has components, and it's really complicated to follow like this. So that's why I had it on ChatGPT. Already explained. Um, Here. Let me open a new one, a new window and bring it to this window. I have several windows open. Okay, so components of forces, they're gonna be X, Y, and Z, as I mentioned, right? Just like the way that they express it with mathematical terms. Okay, so, oh, but this is because I was talking about FA and avionics before. Never mind. I'll just do it here. So a force, can I do this a little better? Let's see like this. A force, okay, a force, sorry, has components in, as a vector. A force is a vector. It's going to be important because their physical quantities that are vectors are physical quantities that are not a vector, and they're physical quantities that are tensors. Right now, we're only dealing with vectors. Other classes like heat transfer, like electrostatics, things like that, have different quantities. Force is a vector. What is a vector? It's a quantity that has a direction and a magnitude. Okay, so force is a vector, and it is defined as components in each dimension, x plus its components in y plus its components in z. We only have 3 dimensions in this world, so it's just 3 dimensions. And they can change in time. They can change in at any moment, right? Like a bridge can have 500 cars at 1 hour and only 2 at different hour, like at noon versus 3 in the morning. Okay, so when a single force has different components, x, y, and z. This one, z is 0 because there's only 2 dimensions, but you can have 3 dimensions. Okay, so if you have more than one force, that means that you have the same thing, and then you can add their components independently. You cannot add forces like they're, you can add the magnitudes, but not the components. How do you find the magnitude? You find the square root of each component. So in the x direction, in the y direction, the z direction, squared. You add them together. So all this is in the videos again, and you find the magnitude. The magnitude is like an absolute value, right? And it's plus if it's in tension and minus if it's in compression. This minus means that it's against its directives coordinate system. Okay, now once you have the magnitude of a force and the magnitude of the second forces, you can add them together, but typically you keep them independent, okay? If you want to add them, you can also add the components and then do a square root of the total components. So in that case, you will add this together and get one value, add these together, another value, these together, another value, and then you square root those quantities squared. Okay, so that's that concept. Forces. There's a whole module about it. Just look it up. Actually, people are doing very good on the homework, which I'll finish grading today. Okay. Then module 3. When you have system of forces, actually, let's use the pencil again. When you have system of forces, a system of forces can be, say, you have this, and it's placed on a structure here, a structure here. Okay, so you're gonna say that this is x and y. So x goes that way, y go up. And then you have a force here. And then you have a force here. And then you have, and this is placing a force here. This is placing a force here. Okay. So since this is y, oh, let's complicate it a little. This is placing a force here. And they will have to tell you at 45 degrees or whatever. Okay. So this is force 1, force 2, 3, 4, 5. So this one, force 1, it's going to be negative F1. And then is on the y-axis. Then this one is 4, 5, is going up. plus force 5 plus force 4. And then this one is not how this force 3 has no components on y, only components on x, because look, that has nothing going up. But force 2 has components on x and y, because we just saw that before, right? So the component on y is in the positive quadrant, and then is F2 times sine or of the angle that they gave us. In this case, is for 45 degrees. All right. So that's the summation of forces that this system has to withhold to be able to stay static. If any of those forces is greater, so if these forces don't add up to 0, this thing is going to start moving. And that's when you have things that break and vibrations and things like that. And mostly with this case, when you have sine and cosines that they start to deal in harmonic ways and stuff like that. All right, same thing here. What is this force? This force is 0. So this is a conceptual question. This force cannot exist, because if this force exists, it will be like a train pulling it. So for this to be 0, this force cannot exist. So F3, if they ask you what is F3, F3 is equal to 0. It's depending on what they ask. If they ask what for, oh my gosh, I'm sorry. F3 is not 0 because this has a component in x direction. I forgot about F2, and that's why I put it there. I'm sorry. So if F2 didn't exist, F3 would be 0. But I remember that's why I put it like that. I apologize. So now we do have to set the system of equations. So F3 in the horizontal axis plus the component in x of force 2. The component in x is the magnitude F2 times the cosine of 45. Yeah, I specifically put the force there so that we would have some x forces. If this force 2 didn't exist, F3 would not have to exist. So F3 will be 0. You don't even have to draw it. And this is equal to 0. So F3 in this case is equal to this. And as you can see, these two forces have to be the same for this to be static. And in magnitude, they're the same. In direction, one is positive and one is negative. So either you choose. Either you say that this is going to be a cable holding it to a wall when you do the design, and this is another cable. It is a bar. This is going to be a bar holding it. So there's going to be in compression, and this is a cable. Like those are things that you'll learn later. Right now, you have to make sure that you know how to find the forces. All right. Now, sometimes you don't have enough information to find the forces. So there's a third concept that we learn in module 2, which is the moment. So at that point, there's where they start giving you distances. So this is x1, x1, this over here will be x2, this over here will be x3, and we'll look at an example. But the whole concept about moments is that they can be added, and moment is a distance times a force. So this force is F1, this distance is x, and it's rotating around the y-axis, right? What is the y-axis that you have to grab and move? Y. So if you hold it like here, it will start moving like a clock handle. So distance parallel to that axis is x, and the force is a perpendicular. Sorry, the force parallel to that axis is force 1, and the distance perpendicular to the axis is x1. That's how you know that it's a moment on the y-axis. So F1 times x is the first moment, not moment of inertia. It's this first static moment. Moment of inertia is a different thing. We'll learn that at the end. Then force 2 is this component, as we said, is F2 sine of 45 times that distance, say is x2. This is F4 times this distance, say is L. F5 is the F times that distance, F5 times that distance, because they're parallel to that axis. This one is the only one that is not parallel. That's why you have to have components. All right, so let's do some examples. Those are the two concepts that we're going to be testing on, this weekend, which is force only has two components, or two qualities, the magnitude in the components, or magnitude and direction, and moment is the force parallel to an axis times its distance to that origin. If you, as the designer later on, decide to put the origin of your system here, which a lot of times you do, like an airplane, which is the center of gravity, then all the moments are with respect to that. That's why airplanes have the fuel tanks on the wings, because they want to maintain the center of gravity as close, sorry, all the force distributions as close to the center of gravity as possible. Okay, let's do examples. Any questions while I look for some examples? Any comments, any discussion, anything at all? Are you able to understand what I'm saying? Is everything clear so far? Ready for examples? Somebody say something.
I
Good.
have a question about the format of the test.
Oh my gosh, yeah, go ahead. Go ahead.
How many questions should we be expecting? And is there going to be like a time limit?
Yes, I guess you weren't here when I mentioned. So you're gonna have from Friday to Monday, and I'm anticipating 4 questions, and you're gonna have access to internet, access to your notes, access to me. So don't worry about those things so much. And this is not on you at all. I'm not stepping on your toes. This is something that I'm gonna tell everybody.
Okay,
At
thank you.
least, at least, yeah. No worries. Everybody, from every single person on this class and every single one of you who's gonna watch this video later. Don't worry so much about significant figures, about how many questions, about the format. Those things are more things that you have to worry about in high school and things like that. Now you're in a setting where you're preparing for projects for your own company, for working in a professional environment. Worry about showing that you know the concept, that you know how to apply it. Um, Worry about asking the right questions, which again, this is something that I've been meaning to tell, but I didn't say it before because I didn't get the question asked until now. So at least with me, worry about like the physical aspects of things. Like, okay, so I don't know, in an airplane, why are the turbines located um, on the front versus the back? Well, some of them are the front, some of them are the back. And when that happens, the profile has to change because of the geometry of the wings. So please start thinking about the actual concepts. That all those other details about the formats are not as important to me. You're gonna get an A if you know the concept, even if you do it on hand or if you do it on a fancy format. Okay, thank you for the question. That was very important to clarify. So I'm thinking about going through some examples from chapter 2 and then some examples for chapter 3, so that helps you with the homework and it helps you with the exam. I'm gonna make sure they're as close as possible to to these to the examples that I provide. All right, so let's see that one of the problems is, this is from one of the books that I follow, which is the Hilbert. Um, okay. All right. Oh my gosh, it's so hard to see. But basically, why is it so difficult to see? Let me see if I can get a better picture. Um, let me see. So that is not good at all. Let's try a different one. Okay, perfect. So let's just focus on the picture. Look, they're giving us a plane and 3 forces. And that could be because a crane is pulling the box while say I know they're trying to keep it static, like they're going to go, I don't know, they're gonna place this on a top of a building, so like a crane is pulling it on this end, and another two cranes are trying to pull it up like this. One of them, yeah, that's just know that there are three forces, and one of them is in compression, and two of them are in tension. Compression is because it's pointing to the object, and the other two are pulling it. One is pointing to, the other two are pulling out of. And the plane is 20 degrees with respect to the horizontal plane. So the first question that you have to answer is, where do I want to put my system of reference? I would always put it in dynamics. Is very easy. Dynamics, you have to put it on the mass because it's moving. So I will train myself, if I were you, to start putting it on the mass so that I am like I understand the concept as I'm working the exercise. So if you were to draw that example or that system of equations, or that is called free body diagram, actually, the free body diagram, then you're gonna have a mass at an angle, okay? And then you're gonna have system of reference. It's gonna be x prime, that is 20 degrees off with respect to the horizontal plane. Sorry, that's not x prime, to the horizontal plane. That's 20 degrees. Okay. And then that means that this alpha, or A, that A is, with respect to your x-axis, is A plus 20. So if you want, you can, if you want, you can say that you actually have this angle, I don't know, beta, and beta is alpha or A, whatever that is, plus 20. And you're gonna do the same thing for every force. So it's really more geometry, trigonometry than anything else. The forces are simple. You just do square root and get all the components together. So you have this force that is 60. Sorry, let's use red for the forces. Oh, sorry. Red for the forces. So this force right here, which is this one, 60. This force right here is 80. So 60 is easy, it's 20 degrees. This force is 80, and this force 120. And then that 120, you also have to find out the location. This is what they call the kinematics. The kinematics is the relationship between the location and the forces. Okay, so and easy peasy, because they're saying that it's also A or alpha. So your y prime has to be 90 degrees from your x prime. This is your y prime. And that means that alpha with respect to y prime is also A or alpha. Let's say it's alpha, which is the same as this alpha. All right. That means that this angle is going to be, I'm actually going to draw it again because this is where you're going to start seeing the magic. So this force 80 and 120, let's do one by one. So 60 has components with respect to x of cosine 20 and sine 20. Okay, so please take notes because I'm not going to write everything down. At this point, I trust you're following. So cosine 20 is this component. Sine 20 is this component. This trigonometric sine of 20 times the 60 newtons or 60 pounds. All right, so this is 60 pounds times sine of 20. This is 60 pounds cosine of 20. All right, and how do you know that that's true? All right, let's do, oh, this is where that thing was. Okay, so Wolfram Alpha is a really good tool I use for calculator if I don't have a calculator on hand, all from alpha. So cosine 20.9396. Okay. So what is 60? So 60 cosine 20 is 5838. Okay, so 5838. Please somebody remember that or write it down. And that's the x component. And sine 20 is 20.52. Okay, so 20.5 squared plus 58.3 squared. I'm going to show you why that is that. Square root. Okay, so it must be 58. Did I get the wrong numbers or not? So if you do the so square root of 20, I'm gonna just show you why this is the magnitude. Okay, so 60 times cosine of 20 and 60 times sine of 20. We're not dealing with exact numbers here. Yeah, there you go, 60. So notice that I'm showing you, demonstrating that this component on the x-axis, and this is the component on the y-axis of that force. That's how architects, well, engineers design with architects, the angle of the ropes, angle of the chains, angle of the bars, angle of the any supporting beam, everything. So on the x, with the angle with respect to the x-axis on the blueprint, it would be 20 degrees. And this 20 degrees on the with respect to sine. Or another way to say it, if you do 60 times cosine of 20, then on the x-axis, that force is, why is it not giving me approximate? 56 times, this is the force with respect to the x-axis, 56.38 newtons. The total force, the magnitude is 60, but with the x component is 56.38. All right, I think that's very clear. So we have that force. If you have questions, just let me know. So we have that force that we would write down for x and for y. Then for 80 is the same concept. You just use, instead of 20, you use a plus 20, but that's the problem. We don't know what alpha is. So what we do is we do a system of equations. Okay, this is where the magic happens. So the system of equations is what I was saying before with a simpler example, but we're gonna do it again. So summation of forces with respect to x. What is it? Well, if you choose, if you would do it with respect to x or with respect to x prime, it's depending what they're asking you. They're asking the total force. So it's up to you what system, what reference you use. If we do it with respect to a prime, we're gonna use this system of coordinates. So it will be 60, right? Because it's on the a prime. This is with respect to a prime. When you choose if you want a prime or a or x, it's depending on how you feel more comfortable. Plus this component, which is 80 cosine of a, which is what they're asking for. The issue with going a plus 20 is that cosine of a plus 20 turns into a different trigonometric function. Cosine of a plus 20 is not the same of cosine of a plus cosine of 20. Right? Cosine of 10 plus cosine of 20 is not the same as cosine of 30. That's why this is this class is more about conceptualizing how to solve it than finding the force, than the meaning of the force itself. Because the meaning of the force is very simple. A force is a magnitude that has a direction and components. but how you get to it is what you need to get very good at. All right, so now that you saw, okay, we have to, and again, that concept is not even statics, it's trigonometric. So this is a trigonometric concept, that cosine of, because let's prove that. If we go back to cosine of alpha, cosine, because maybe I'm not remembering my trigonometry very well. Cosine of 10 plus cosine of 20 is 1.92. All right, 1.92. What is cosine of 30? See how it's not the same? So that's why you have to choose, you have to make sure that you choose the right system of equations. The right system of equations in this case is just where cosine of A, so we can find A. Because one of the questions is, what is that angle A or alpha? What else? Well, we have another force. That one is pointing to the right, is positive. This one is pointing up, is positive. This one is also pointing to the right, even though it comes from the left, is where they point. It's where the force is pointing to. If any force is pointing to the left, that will be a negative force. But they're pointing to the right on a system of reference that I said that is positive if it goes to the right. All right, so plus, I know I'm saying a lot of things and it might sound complicated, but no, I promise you, super simple. It's just a simple rule. Playing Monopoly is way more difficult than this. Playing chess is way more difficult than this, I promise you. 120 times what? What? Somebody tell me, 120, which cosine or sine of A? Who's here? Celeste, what do you think? Or Nina, or Rosaline, or Emilio? What is so? Is,
So for 120, I'm thinking it's going to be sine of A just because it's oriented differently. Like the origin point we have,
but
the horizontal.
remember. Thank you for participating because that's telling me how bad or good I'm able to explain. So the x-axis that we chose is this inclined plane. This is the x-axis. So the component on the x-axis of this 64 is here. The component on the 80 pounds is projected here. The component on the x-axis of this 120 is projected here. These are triangles. These are triangles, okay? The component on the y-axis of this force is projected here. I know I'm confusing you. Okay, I know why I'm confusing you. This right here is the y component of 80 pounds. This right here is this y is the x component of the 80 pound and the 60 pound. The 60 pound has no y component because it's completely perpendicular to y. This right here is the x component of the 120 pounds because it's parallel to the plane. This right here is the y component of the 120 pounds. Does that make sense? So if you take this as three different triangles, so this is triangle number one, 100, 120, and the plane is right here. This component, remember, this is trigonometry. If we need to study trigonometry, then we're gonna have to do that too. But I'm expecting you know that. This component of the triangle is going to be translated here. This y is what is gonna cut it here. Okay, so this is the x component, this is the y. Why? Because the 90 degrees is right there. The force is always the hypotenuse. The magnitude of the force is always the hypotenuse. When they give you a force drawing or a force illustrated, that is always the hypotenuse. That's always the magnitude. From now on, magnitude equals hypotenuse. The same way you always say, I don't know, a good example that I'm trying to make a silly example. The same way you say, I don't know, Nike equals just do it, or Harley Davidson equals freedom. Like kind of like they try to associate these things. I associate from now on. Force illustrated equals magnitude equals hypotenuse, or magnitude of the force equals hypotenuse. So the hypotenuse is 120. Where are the sides? The sides are x and y. Where is y? Well, y is here. Where is x? X is 90 degrees from it. Oh, this is x. What is the x component? The y, the one right here. What is the y component? The y right here. What about this triangle? What about this triangle? This triangle has a y component right here, an x component right here. Everybody follow or any questions? We have, this is, if we don't understand this, we're not gonna do good on the test. Any questions, any concerns? At the moment you understand this, you have this class figured out. It's just, before you solve the exam, look at it for 2 minutes. Go get a snack, come back. Go get a coffee, come back. Solving this is super simple once you have figured out where are the triangles, where are the magnitudes, where angles are where. There's not gonna be curved forces. There's no such thing as a curved force. There's a curved field, but that's different. You don't learn that today. You don't learn this semester. You learn it when you take quantum mechanics and things like that, or mechanical materials. Everything here is just triangles, and yeah, it's just triangles. It's not that complicated. So this is the moment for everybody to understand this. So ask me any question, anything at all based on this drawing, based on this illustration. This is the moment to ask. Don't be embarrassed. I might be explaining too fast or too complicated. Everybody on the same page? Yeah, can I carry on? All right. Please don't be embarrassed if it's something that is not. I'm used to seeing the, yeah, okay, good. I'm used to seeing this, so it's easy for me, but I know it's new for a lot of you. All right, so the x component is right here, 120 times sine. Wait, hold on. You said sine or cosine?
Sine.
You got it. You got it. You got it. Sorry, you got it. Yeah, so you got it because the opposite is sine. All right, all right, all right. Good. You got it. So all that explanation that I gave you was hopefully not too redundant. The one that is pointing to the parallel to the x-axis, to the x prime axis or a prime axis is sine of 20. Okay, everybody needs to understand that. That means that this is, or sine of alpha, I'm sorry, sine of alpha. That means that we have an equation, this is alpha 2. I'm gonna say alpha because they're saying a here, and this looks like an alpha. So the equation is 60 pounds plus 80 cosine of alpha plus 120 sine of alpha equals to 0. Next semester, for those of you who take dynamics, this will be equals to mass times acceleration. Right now, it's equal to 0. Therefore, you have to get a good calculator or learn your trigonometrics because you have to solve for alpha. You have one equation, one unknown. All right, let's do system of equations for y. So maybe it will be even easier to solve. Actually, I take it back. You have one equation, two unknowns because cosine of alpha is different than sine of alpha. So you have one equation, two unknowns. It's like 80 times p plus 120 times q. Yeah, because this is one value and this is a different value. So even though it's the same angle, you have one equation, two unknowns. That's why we're gonna have a second equation. So somebody tell me, with all this mess that I made here, or I think I can fix it. Somebody tell me, oh man, it's gonna draw. Somebody tell me what is the value of the forces on y? Celeste or somebody, or Rosalind or whoever.
Shouldn't it be 80 sine alpha with 120 cosine alpha?
1 second. All right, say it again.
80 sine of alpha and 120 cosine of
You got
alpha.
it. Beautiful. Yeah, yeah, that's it. It's plus or minus?
I think it would be 80 is positive and 120 is negative because it's
Yeah.
going into the.
Exactly, because you have the origin of a triangle here, so that and that. So it's going to the opposite side of the system of reference. Usually the triangle will be pointed out of the origin. So minus, another thing to remember, 120 cosine of alpha. All right. And then it's just a matter of solving it. That's what a lot of people get issues. This is equal to 0. So very good job. Very, very good job. See, this is as hard as it gets. It's just a matter of knowing what goes with what and solving the system. And sadly, sometimes we get issues solving the system here. So you can do all the techniques that you learned. You can say 80 sine of alpha minus 100 cosine of alpha equals to 0. That's add them together. One of the things that you can do is check. That's why you're gonna have access to internet. You can check with ChatGPT. You can check with Wolfram Alpha. You can check on your books. So if you divide, remember, if you divide cosine alpha, what you get? No? Okay, so maybe see, that's what most people, every student, I would say every student I meet is okay to understand, knows the concepts. Like you do very well. Is when they solve this that they're like, well, what do we do? So notice that you have if you divide each term by cosine of alpha, you're gonna get 80. I'm gonna take a screenshot of this set of equations. So we solve them together. All right. All right, let's start from there. Okay, so if you divide everything by alpha, because you have cosine alpha, sine alpha, sine alpha, cosine alpha. So cosine alpha versus cosine versus sine alpha, or sine alpha versus divided by cosine alpha is gonna be 80. Oops. Tangent alpha minus 120 equals to 0. So cosine alpha divided by cosine alpha equals 1. Sine alpha divided by cosine alpha divided is tan alpha. How many of you don't know this? If you divide this by cosine alpha. How many of you don't know this? I'm waiting for hands up or me or... Okay, good. Everybody understand that. So in that case, you're able to find alpha. And how many of you know that you can do this? How many of you realize that this is something that you can do? You can divide this by cosine of alpha, even though the equation is only sine alpha minus cosine alpha. Do you agree that you can do this or no? Cool, cool. So this is cool. So if this is cool, I'm gonna carry on. If you have questions, please let me know. This is again, this is trigonometry. This is not even statics. This is just pure math. Sine of alpha. If it's different, if the angles are different, that you cannot do. But if it's the same angle, sine and cosine, give you tangent. So in that case, all you have to do is tangent inverse. Every calculator does this, or Google or ChatGPT, of 120 pounds divided by 80 pounds equals 256.1 degree. All right. Then you go back and you put 56.1 degree in this equation. 60 plus 80 cosine of 60, 56. Always make sure that you have it in radians, not, sorry. Make sure you have it in degrees, not radians. Radians is where you're dealing with frequencies. You have 2 pi, you know, no, in this class, make sure you always have it in degrees because it's Cartesian coordinates. It's not frequencies. So it's not based on the revolutions. Okay, so cosine of 56.1, sine 56.1, multiply them, and this will be give you whatever the force is. Okay. Yeah, that's it. They're only asking us to find alpha. This is it. See, it's not, it looks pretty complicated, but it's just following the concepts. Questions, concerns, so we can move to a different one. No questions? Let's move to a different one. Yay, nay? You want us to stop here? I'm getting one. Okay, let's move on. Everybody okay with moving on? All right. I'm gonna take that silence as no news is good news. All right, let's get in. So that's module 2. Let's get into a different problem. I think we should do one for module 3, where you get the moment. So here, let me look for a good example. 1 second. So, one that gives us moments. I think this one should be pretty good. So, let me take a screenshot of the image. All right, yeah, I found it. This one should be good enough. Okay, this one only has one force, but is good enough. All right. And it says, what is this? What is the question at? Where is the question? Why are they asking a 300 Newton? Oh, let me bring that too. Was trying to take a picture of it or a screenshot. And I don't see the thingy. Oh, here it is. Oh, I got the wrong document. Sorry. Uh, no, it's too small. But I think this example would be good. Okay, so different questions here. Okay, so it says 300 Newton force is applied at point A. Right there. Determine the moment with respect to D and the smallest force applied at B as Bravo that creates the same moment at delta. So there are two questions. What is the moment of the force at delta? And the smallest force at that point. Okay. So, all right. So one way to do this is to create the triangles. And I actually have that already done here. So instead of drawing it, I think I can just copy paste that. Okay. So if they give you millimeters, always take it to meters. If they give you inches, always take it to feet. So the force is 300 newtons, and it's 20 degrees with respect to parallel axis to x. You put your coordinates right here at the point D. If they're asking you for a moment, you always put the coordinate at that point. That is the first thing you have to know. Moment will always have the coordinates at that point. All right, and then it's 200, I suppose, 0.2 meters, 0.1 meters, and then you just find R prime. So R prime is just a geometrical determination is the square root of 0.1 squared plus 0.2 squared. So the f of x, and remember this is 25. So that will be the same. So this triangle right here is 25. That's the component of the force. So one thing is the component of the force, and one thing is the distance he has to travel. So the distance he has to travel is this, in Y and this in X. So the force in X for that force A is the magnitude 300 times cosine of 25. That will give us the magnitude of that component right there. And in Y equals 300 sine 25. All right. Somebody tell me that in calculator, please, and tell me something this in the calculator, please. All right.
For 300 cosine 25, I
Yep.
think it's 271.9.
All right, there you go, 271.9. And the other one?
300 sine. 126.8.
126.8. There you go. One significant figure is good enough for me. If you were to put 127, that will be okay too. So don't worry about those things.
Okay.
All right. So if you want to know what is the components of each thing, so the components of F are 271, let's say 272 I, which is the unit vector for X. It's not imaginary numbers, it's the unit vector, plus, in this case it's plus because it's a positive number. If it was negative, it would be because it's a compression, but it's extension. 126.8 J. And if it's 3D, it will be K. So the next one will be, or in this case, actually you can say 0 K. There's no component in Z. All right, why? So you have an option. You can do yeah, let's find that. Let's find that value. So what is the moment of that? What is the moment? Is 272 times the vertical distance, the parallel distance. What is the parallel distance? Is it 0.2 or 0.1 for the component in X? This force. What is the parallel distance? 0.2 or 0.1? What do you guys think? If I apply this force like this thing is going to start rotating like that. So the parallel distance is this. If I apply the force like this, it's going to start rotating like this. So the parallel distance is this. You know what I mean? So is the force and the parallel distance. So the y component, the parallel distance is this. So y component times 0.1 and the x component times 0.2. Everybody get that? Yes? No? Any questions?
Yes.
Okay. All right. Now, you have to decide which rotation is positive and what rotation is negative. The standard, and I advise you do this so you don't get confused because it's like the most standard way in physics, is the counterclockwise rotations are positive and clockwise rotations are negative. So if you have a force, the component in y is this, which is sine. So this one is the component in y. This one is the component in x. And you have a force that the component in x is right here. That force will have a distance of 0.1 meters, and it's making it rotate clockwise. So that moment is negative. This force has a perpendicular distance that is 0.2. It is making it rotate counterclockwise. It's making it rotate like that, counterclockwise. If this is a roll, like it's just placed here. This is the fixed point D. So this is a positive rotation. Okay, so we're gonna do that next. So in the moment is also a vector. 272 is in X direction, remember. 272, somebody's really trying to get 272 times the distance. So this is newtons or pounds. Yeah, newtons. Times the distance, which is 0.2, right? Right? I'm gonna say yes. 0.2 minus, because the next one is gonna make it rotate counterclockwise, which is negative. That force in Y is 127 times 0.1 meters in J. And this is in I. This is the components. All right, what is 272 times 0.2? What, 90? No, that would be 60. 6 times 7, what is 50 what? Let's say 60, since you guys are not telling me.
54.4.
54.4, thank you. All right, so you're gonna be in charge of my math. 54, 55. Thank you much. And then this is 12.7. This is in X. This is 12.7, right? 127.1. Actually, in the exam, if you don't have a calculator, just do round numbers. 0.1 and J. All right. So the thing that I want you to realize is that if this, oh man, you messed up. I messed up. If we do I and J, this is the right hand rule. This is the right hand rule. I messed up. So I cross J is K. So this is in K. Yeah, because this is gonna be parallel to K. I cross J is K, and I cross negative J is negative K. So K. So these components are positive K and negative K. You know why? I don't think I mentioned why. So this is the right hand rule. If you have a moment, I'm gonna open my camera again for this. So that's why cement trucks rotate always in the same direction, because they're moving forward and they have to rotate in that direction. If they rotate the opposite direction, they will tilt. So you have right hand rule is your x-axis is your index, your y-axis is your thumb, and the way you rotate is your z-axis. Okay, so if you have a force in x and you have a direction in y, and you apply that force, it's gonna rotate positive K. I'm gonna send a video about this because this is something that you really need to learn in person. It's hard to complicate. How many of you know about the right hand rule? Never heard of it before? This is for magnetic fields, for electric fields. Okay, good. Some of you know. So this force is in X, this direction is in Y, the resultant is in K. Okay? This force is in X, the distance is in negative Y, or sorry, direction is in Y, but the resultant is in negative K. Okay, so K and K just add together is the forces that will have they will add up. They do not go and do square root. You don't do square root of them. The moment you don't do the magnitude as square root, you add them up. So 12 is 55 minus 12.7. That if it's 13, that'll be 42. So this is 42.3 or 41 point. See, let's say 42.3. And this is Newton per meter. This is the unit of K. Unit per meter in the K direction. All right. How many feel comfortable with this? Is it clear? Is it confusing? Very confusing? Is it straightforward? All right. I think I know. I'm gonna do another one. Let's do another one because it's kind of confusing. But then when you start doing it, it's just like learning a new game kind of thing. The rules are pretty straightforward. All right. So let's do this one, which is one of the assignments, the problems in the assignment. Again, you go millimeters to meters. All right, let's do this one. So an actuator, which is a foot valve, is hinged at B for beta or Bravo, knowing that A equals 28 degrees, determine the moment of the 16 Newton force at B. All right, so I'm gonna place the the system of, or the free body diagram. That's right here. All right. So this is the platform. This is used for like a counter. This is used in industry as a counter. It will open and close for when the lid of a bottle gets situated here, and they know that the force from the injectors are about 16 newtons, then the actuator will move. So this is a real example. So you have 0.17 meters from the point of the valve rotating to where the force is applied. You have 20 degrees with respect to the horizontal, and you have 28 degrees with respect to the x-axis or the x. Okay, well, let's stop there. If you take 16 newtons, 16 newtons, and you form the triangle, you're gonna have a force right here, a force right there, and a 90 degrees. This is 16, and this is the y component, and this is the x component, and this is your 28 degrees. Okay, so this is for the homework, so I'm gonna provide the angles. Oh no, I already have it here. So notice that alpha, if you follow this, you have this whole thing is 28. So they're saying that the foot valve, knowing that A equals 28, so from here to here is, oh yeah, sorry, this is not alpha. I'm confusing you. That is not alpha. Let's erase that. Alpha is with respect to this plane. Alpha is respect to the actual platform. So that whole thing is 28. All right. So we're gonna have to name a new angle. So this angle right here says theta. So theta equals 20 alpha minus 20. Or how do we know what that is? Yes, because 20 is right here. Yeah. Okay. So 20 is right here. This, if you have, this is a law. Remember, this is from trigonometry. If this is 20, then you can say that this is 20. You're just moving the horizontal up. Okay, and if the force is right here, then alpha is whatever this beta is minus 20. Okay, so yeah, 28. So alpha minus 20 is theta. And they tell us that that whole thing alpha is 28, so theta equals 8 degrees. All right, that was the first complicated part, finding that angle. All right, so in that case, it's pretty simple because once you, that's, as you notice, that is the most complicated part, setting up the equations. So 16, so F forces in X equals 16 cosine of 8, right? And meanwhile, somebody tell me what cosine of 8 times 16 is. And forces in Y is 16 sine 8. What are these two things?
Cosine 8 is 15.8.
Mm-hmm.
Sine 8 is 2.2.
All right. This is in X. This is in Y. I and J. Okay, cool. Thank you so much. Right, so now all we have to do is the perpendicular direction to the forces. So, as you notice, this force right here also has components. Okay, so that is 20. So what is 0.17 cosine 20? 0.17 cosine 20.
0.16.
Cos 20 equals 1.6 or 0.6.
0.16.
Beautiful. This is meters. And this is this component. And what is a sine of 0.17 sine of 20?
0.06.
0.06. Beautiful. So this component is 0.06. This component is point. That's why I wanted to. I'm okay to meet it in person because writing with a mouse is too difficult. And I really need to get a stylus or something for these meetings. Okay. So finally, the moment with respect to B, where I am calling out that any rotation counterclockwise is positive, is equal to the force in X times the distance in Y. So X, that distance X prime times Fy plus the distance Y prime times Fx. And if there's any more forces, you just do all the components in Y times all the distances in X plus all the components in X times the distances in Y. Okay, but this is only one force. All right, so that means that we have X prime, which you told me it's 0.16. So 0.16, it's a point right here, meters, times that force in Y, which is 2.2. And we have that is rotating counterclockwise, right? Because this force right here is making it, and it's pressed right here, so it's making it go counterclockwise. And this force right here is also making it go counterclockwise, so it's positive plus the distance in Y, which is 0.06 times the force, which is 15.8. All right. What is that? 0.16 times 0.2 and
1.3
what is the whole thing? 1.3?
should be 1.3.
Yeah, so that is our answer. The newtons per meter. So determine the moment of, this is also a torque. Moment is related to torque. Later on, you'll change the word moment for torque. Torque came later on when the internal engine was invented and they had a rotating mechanism. When they first started, they called it a moment. But if it makes more sense to you, you can call it a torque. But when they call for moment, this is what I mean, torque. So the moment is 1.3 newtons per meter. This is example number 1. All right. This is all the time we have for today. If you have any more questions, feel free to let me know. Any last questions, any last comments?
This isn't on the review. It was more on the homework that you released for the solutions. For number 3, part B, I was wondering if we use the 360 newtons as the final answer or the 970 newtons.
Can you share your screen?
Yes. See, share. Oh, disable share.
Whoa, sorry. Share. Wait, what? How come you can't share? Yeah, for some reason you're not able to share. Hold on, let me open it. I don't know if I was supposed to set that up beforehand or what. Usually tells me multiple participants can share. Here, let me open it. Talking about homework 1, right?
Yes, homework 1, part question 3, part B is because like you solved for PY for 1 and then PY ended up being a different final answer. So I was just wondering which of the 2 we should go with.
Problem 3. Problem 3, part B.
Yes.
Oh wow, yeah, there's you're correct. So 325 is the horizontal component. 970 is the distance. Yeah, this is wrong. I apologize. That is wrong. Should be 360.
Okay. Thank you for the clarification.
Thank you for letting me know that it's the wrong answer. Didn't realize.
Thank you for your help, Professor. You have a good
Yeah.
one.
Ciao. Talk to you later. Bye.